Consider the complex number z is root 3 plus I. Show that for all positive integers n, z to the n take away the conjugate of z to the n is 2 to the n plus 1 sine n pi by 6 I. Well, let's look at z to start with. So it's root 3 and 1, and that means that 3 plus 1 is 4, square root that, so that's 2. And this angle here would be pi by 6, the inverse tan of 1 over root 3. And so we can say that z is 2 cis pi by 6. And that means that z to the n would be 2 to the n cis n pi by 6. The conjugate would be 2 cis negative pi by 6, which means that z bar to the n would be 2 to the n cis negative n pi by 6. So, z to the n take away z bar to the n would be, so let's think about this, it's going to be 2 to the n into cos n pi by 6 plus I sine n pi by 6. Take away 2 to the n cos negative n pi by 6 plus I sine negative n pi by 6. Now, cosine is an even function and sine is an odd function. So what we have is 2 to the n cos n pi by 6 plus I sine n pi by 6. Now, because cos is an even function, not 2n, 2 to the n here, this one will be the same as cos n pi by 6, but this one will be negative I sine n pi by 6. So, these are going to cancel out, and what we're going to have is 2n is 2 to the n I sine n pi by 6 plus 2 to the n I sine n pi by 6. So that's 2 of those. So that's 2 to the n plus 1 I sine n pi by 6 as required.